I believe we are both live in the webinar and on the live stream at this point. Hi, everyone. I'm David Groom, often known online as iShotJR. I'm Make's community editor and your host tonight for the Make Volume 93 launch party. This is Make Volume 93. It's all about robots. We explore the world of humanoid robots and how you can use AI and open source to build bots from humanoid heads to four-legged friends, plus 17 projects, including a robot arm drawbot. Volume 93 is on newsstands now. If you're a subscriber, you should have already got it in the mail, as I have myself. You can get it from the Maker Shed at makershed.com, or you can subscribe at make.co. I also want to direct you, and I'll drop this in the chat, and we'll have it in the links below later, to our Discord server. If you want to connect with us after the show, you can just go to makezine.com/go/discord, and we will stick that link in all the relevant places for you as well. And I would like to, at this time, bring in our guests and introduce each of them. Here they come. It takes a couple seconds. All right. Our first guest is Michael Brady, the creator of Voxhead. He's a designer, a software engineer, a cognitive scientist, and a digital nomad. He teaches software engineering and embedded computing and likes writing science fiction. Also, Nathan Cow, the creator of Pupper, and in fact, a family of open source robotic dogs, including Doggo and Pupper. In collaboration with Hands-On Robotics, he developed an open source college course using those robots as a learning platform. After a stint as a robotics research engineer, Nathan is now working on a robotics startup. And Lee Wilkins is an artist, cyborg, technologist, and educator. Welcome, everyone.
Thank you.
Awesome. Okay. Well, first up, we want to talk to Michael about Voxhead, which is prominently featured in this issue. So, Michael, tell us about your project.
Yes, hi, great. Well, so first of all, I just want to thank Make Magazine for putting us on the cover. That was really a real big boost for us. We have lots of people who are asking to be beta testers and things now. So it was really great to have us on the. So thank you everybody for supporting us. So yeah, let me tell you a little bit about Voxhead. So it's kind of an open platform plastic 3D printed robot, and it's a life-sized human head. We're working on arms and hands for it also, so you can upgrade to for it to have arms and hands. And it's really in the beta testing phase. So we're trying to get it out there for lots of people to be able to build these things. The STL files are open, and the software, there's software that's free for it. And we're hoping to get developers to create software for it and to add to the platform. So that's one of the big reasons we're making it open so I guess I could tell you the history of it, or I mean, whatever questions you have, feel free to jump in with questions, but I'll just talk.
First question, I'm curious, is what can you do with it?
Originally, so I guess let me talk about the history of it a little bit, because that's where it was designed for, was for basically research and cognitive science as kind of as a tool for doing embodied cognition kinds of things. But then I started working with autistic. I have a friend who works with autistic kids, and he invited me one day to come to bring the robot to the center where he was working, and the therapists all were really excited about it, because the kids they don't like to make eye contact with people, and they're slow at learning gestures and things. But when we put this up there, the kids were just like right in front of it, trying to make eye contact and trying to get it to move and do things and interact with them. And so the therapists were just really, really excited about that. So that's one of the directions we've been going in, is to try to develop that I've been going in, is to try to develop it as kind of as a tool to help, really as a low cost tool. One of the problems, there are a number of robots out there that are designed for kind of robot intervention and therapies kinds of things, but they're really expensive, and so parents are just too stressed out about these things to really want to have these in their homes. because the first thing the child on the autistic spectrum will probably do is break it, and so we want to make sure that it's something that's not going to stress the parents out. So that's one direction, but there's all kinds of directions. There's I mean, you can use it as an Alexa device. There's you could use it as we're thinking about maybe video games or something, but it's basically we're just getting it out there. I'm doing it because I've developed it as a hobby for all these years, and then during COVID, I decided, well, let's just make this something that other people can use too. So that's been kind of the project, and who knows what people will come up with. It's there's so many different directions, I think. So assisted living and language tutor and I mean, there's been all kinds of ideas. Driverless cars, and in cities sometimes you need a head that can do kind of communication with pedestrians, so pedestrians have to look at a car and not, if there's a robot head there that kind of look and wave that, oh, okay, it's safe to cross. Maybe that's a direction that who knows? I mean, really, there's the field is wide open.
I had
And it's
mentioned,
also
oh, go
oh,
ahead, Michael.
it's also kind of filling a gap. So if you see all these humanoid robots out there, life-size humanoid robots, they all have like motorcycle helmets as faces. There's no eyes, there's no cameras, there's no mouth. There's really no way to the speech communication there. I think they're all putting that off to the end, but I think speech interaction with people is the bottleneck that's going to get to robots to be more pervasive, I think, in the world. So I don't know why they're working on legs and not working on faces, So anyway, that's kind of the gap we're trying to fill. But again, it's open source, and it's anybody who wants to build one of these that's the idea.
You're saying about driverless cars, and I thought it was kind of funny, the idea of driverless cars and then putting a robot driver in it. But I mentioned when we were backstage earlier that I was at the University of Michigan Robotics Lab earlier today, and they were saying one of the hardest things in autonomous vehicles is four-way stops, because you might not realize it, but when people come to a four-way stop, you're actually like looking or gesturing or saying like, no, you go ahead, or even just like, little subtle things that you might even not realize are happening. And when there's nobody in the car, there's nobody to
Yeah,
like nod
yeah.
or like wave or whatever like that. So that's actually a really interesting application.
Yeah, yeah. So that's hopefully maybe that's one direction. Uh, I imagine that, it's really hard to imagine 10 years from now what kinds of robots we're going to see out there. But part of this is to try to drive robots into sort of more of a humanity. Robots are coming. It's basically inevitable, but we want good robots. So I think like trying to put a face on it, and not like some of these, rubber faces with hair and things like that. I think that's a little bit too much. I don't think we need to go that far, but I think we do need, yeah, yeah, what we see on the
Well,
cover
one of the
here.
things that when we were working on the cover for the magazine, one of the things I said is like, this is like the least creepy robot face I've seen ever. Like, usually they're either, evil looking or trying too hard to look real, but then ending up just creepy. And this is like the most kind of like benevolent and gentle and soft expression I've ever seen a robot make.
Thank you. Yeah, that's that we were. I mean, I'm saying I keep saying we, but that's something I was really going for. I'm talking to other people. I know a lot of people who do human robot interaction, professors, and talking with them. So having the eyebrows was something like eyebrows and the eyelids give it really basically enough sort of affect, that it can, kind of change its sort of happy, sad, high energy, low energy kind of parameters. But other than that, I think rubber skin and smiles and a brow that can wrinkle and things is a little bit cost prohibitive too. It's if people want to build these things themselves, as soon as you start talking about silicon skin, it really is. It makes it much more difficult. And I don't think it's really needed, to be honest. So
Uh,
I figured out how to do a mouth that was closed and it doesn't really have big cracks that open up the face, and so it trying to avoid the creepy kind of underskin, or skull-like looking face too. So
I think Keith's trying to jump
I
in
was
with a
going to say,
question or a comment.
that's one thing I like about this project is that, um, you know, understanding the intention of, we're trying to program machines to understand human intention with AI and to parse our language and to figure out what we want, what answer we want them to return, what action we want them to take. But we need to understand what the robot is trying to communicate as well. And using facial expression and gesture and body language, that's tapping into millions of years of evolution of animals that understand body language. A cocked head, I don't understand. A look of surprise, a look of,
Right. Yeah.
you know, we have so many non-verbal, non-text, non-speech cues to understanding someone's meaning and intent. And so these projects that try to tap into that, I think, are the future of robot interaction. We need to take advantage of our own programming, millions of years of evolution, just reading facial expressions and body cues.
Yeah, I agree so much. And also the gaze following. I think so that's one thing I've really tried to get in this is in communication to see where somebody's looking is a huge cue in speech communication. I think a lot of the AI stuff is so text. I mean, so the origins of all this AI is text processing, and so the text processing just doesn't incorporate gaze and laughter and grunts and things like that. So a lot of these chatbots, even trying to plug a chatbot into this, you realize all the things about speech that don't really show up in the chatbots that are important cues. Yeah.
Well, and I think that to some degree that the the art of animation and cartooning has already proven to us that we can understand facial expressions with very simple line work. We don't need a million muscles in the face and a lot of wrinkly skin. We get it.
Yeah.
I can draw you a cartoon face with a few lines that fully conveys the facial expression.
Yeah.
But gaze following is the other thing I wanted to ask you about. Anyway, this is sort of the intersection between animatronics and animation and uh, you know,
Oh, okay.
we see it in so many different fields at Make. It's the same crossover between 3D design of characters and trying to animate real world animatronics and
Yeah.
robotics to be those characters. The other thing that you mentioned that's interesting is the gaze following. You have actual eye cams. Those are not just expressive eyes. Those are actually
Right. There's cameras in the eyes, and
directing.
then also the eyes are about the same size as human eyes. So a lot of so there's for instance, Will Cogley's he has a great he's got a new face coming out he's a great designer. But he makes eyes that are about I don't remember the exact measurements, but about 30% bigger than human eyes. I think maybe it makes it sort of more cute and puppet, more likable. But also, I mean, also trying to fit everything into a little eye is really that was a real challenge. It took a long time to get everything to fit into a human-sized eye. But I think that's really important because then you can have eyelids that open up wide enough that you see the whites of the eyes. So yeah, having the right size eyes, I think, is also something that I was really trying to get correct. And I think the gaze following. So my understanding is, the new InMove head also is basically using the Cogley's design for the eyes, and he's set it up so he can get cameras in the eyes now, is my understanding. So I'll be really curious to see. I haven't actually seen one yet, but supposedly the new InMove has cameras in the eyes too. So that's exciting. It's good that
Yeah,
there are robots out there
we put Will's eyes on the cover last year, I think, for
yeah.
an animatronics issue.
Yeah. He's a
Just
great designer.
just for the expressive qualities of character design and animatronics.
Yeah.
But now it's being incorporated into actual robotics. That's great.
Yeah.
I'm just keeping
Yeah.
an eye on the chat here.
Okay.
Alex says, referring back to something we were talking about earlier, let alone perceiving cues that are different across cultures. When we're talking about the ability to perceive social cues by having a physical robot. And Michael mentions the Uncanny Valley question in terms of the decision to make it realistic or not realistic or fail to make it realistic. There.
Oh, so you want so the Uncanny Valley. So I have very mixed feelings about the Uncanny Valley. I'm not really sure what people love to watch zombie movies. So what and they're my experience is people come up to this robot and they stare at it, they gaze at it, they look at it longer than they look at people. They want to interact with it. They just they don't seem scared or intimidated or creeped out by it whatsoever. But even with the even more realistic robots like Amica, um, people are kind of engaged by it. So I'm not really sure what the uncanny. In fact, I think research on the Uncanny Valley is what's scaring off all these humanoid developers, all the big guys, like Figure and Optimus and things. They just have motorcycle helmets. I think they're afraid of the Uncanny Valley, maybe overly afraid. So I'm boldly going forward. The Uncanny Valley doesn't worry me. But again, I don't think there's any real need to do the plastic skin and the hair and stuff, unless you're doing sex dolls or something like that. And even then, I'm not, I don't know, maybe the Uncanny Valley is creepy in that sense too. But I kind of just don't worry about the Uncanny Valley so much. I think it's more conjecture than even a real
I
theory.
feel like that's where you get the uncanny valleys when you're trying to be hyper realistic. So it's like, okay, skin, hair, makeup, everything looks like a real person, except those eyes are just too dead. There's something wrong with that.
Yeah.
That's when you get skeeved out by like, is this a person who's ill? Is this a person who it just doesn't that's going too far in the direction of realism is where you're never quite going to get there with the eye.
Yeah, I mean, there's so many
Face
aspects
following
of
and eye
yeah.
cams is going to get us there eventually, but to me that's the creepy dead spot right now is the eyes
Yeah,
are dead.
and I think there's lots of different kinds of uncanny valleys. So there's sort of behavioral realism and visual realism and audio realism and uh, and it depends on the context of the person. And maybe it's just a temporary. The uncanny valley is kind of how society thinks now, but maybe in 10 years the uncanny valley will don't not even really be a thing. Or maybe it'll even be stronger. Um, and then, I mean, so they say the uncanny valley, from the robot side, it goes into the uncanny valley. And then from human side, if you have like Michael Jackson is sort of like on the human side goes sort of into the uncanny valley a little bit or too much plastic surgery and things like that. So we're not necessarily talking about a robot in the uncanny valley also. Some people can kind of get in there too. So, I mean, real people. So, and they have, behavioral realism, but I think the visual stuff is probably the main one. And that's, but to just get that curve, I think that's like 5 or 10 parameters to get that. And I'm not sure. It's just, I think, a philosopher that drew a line but there's no real science that draws that line. It's just but it's one of the things in robotics that's made it into pop culture and Hollywood kinds of things. So.
I have a question, Michael. We've got about a minute left with Michael,
Okay.
by the way. So if anyone has any questions, please drop them into the Q&A, or if I'm also trying to grab stuff out of the chat as well.
Okay.
Actually, real quick, Alex says, yes, humans already don't have a great record of responding well to other people with slight visible differences. Excellent point. So Michael, I was going to ask you real quick. Again, when I was talking to the University of Michigan robotics professor, they were saying that right now, for bipedal robotics, they are mostly using deterministic algorithms. And this is a very intentional segue into our next guest. But
Okay.
is everything sort of pre-programmed with Voxhead, or is there any sort of machine learning where Voxhead is giving itself its own gestures and things like that?
Oh, that's a great question. And I have a really long answer for that, so I guess I'll have to do the short answer. But yes, that's so my whole career has been in neural networks and developing neural networks, and so I have one thing I'm working on is the skeletal tracking. So what's called mocap, motion capture, and this is for the arms and for the whole, but also just something for the head. So you can watch it can watch a video of somebody talking and then mimic those gestures, those eyebrow movements, and as much as possible. I mean, the head isn't really the main priority, but yes, the short answer is yeah, I use a lot of dynamical systems, and so but it can do both. It can use pre-programmed. That's much faster to use pre-programmed coordinated motor movements. So we have a little sequencer built in. And also you can have it spontaneously generate movements. You just have to have it. somehow know where the illegal parts are. So if like the arm is moving, you don't want to try to move the arm through the head and things like that. So you have to have kind of this train it to where the motions are legal motions for the robot to move. But otherwise, it can just kind of move around randomly, or it can teach itself to move based on videos. But that's all coming. That's not part of what's the beta
Yeah.
testing stuff that's coming out right
Yeah.
now.
Awesome.
We have.
Michael, I came in I'd love, as you make progress in those areas, we'd love to have more articles.
Yeah, I'd love to. I already have another article ready. I'll send a proposal for you. I'm working on a I'm testing the various microcontrollers to do the feedback loops on computer vision. So I have this, I don't know if I showed this, but the little Cyclops version. So if people don't want it's about $500 for the components to build the full head, and then plus the 3D parts in the computer. But for this, it's less than $100. It's just a camera and a couple of little motors and a motor controller. So if you want to start with computer vision and use one eye, so I'm testing with like 5 different systems. So the fastest one right now is the Jetson Orin Nano combined with a little IMX 219 camera that is designed for the CSI slot in the camera. So that's the fastest. That does about 30 frames a second. But I haven't tested the other ones yet. So I'm working with an ESP32 now, and testing to see. So if you're interested in an article on that, that would be.
Yeah, absolutely. And I just think that one
review.
eye platform is really nice for education. It's, a way of getting into the space and doing some of that testing.
Yeah, thank you. Yeah, that's the idea is to like have the most minimal thing, and then people can just keep add another eye, and then add the mouth and the head and then the neck and then if they so it's a good way to get started.
Awesome.
Exactly.
Well, I was trying to set myself up.
Aliens with 3 eyes.
Yes, add a couple more.
Yeah. You can put as many eyes as you want. Yeah, I mean you can hybrid, all kinds of systems. I'd love to build a wall of all these things and just kind of sit and watch people, that
Yeah.
An art exhibit kind of thing.
Good.
So I was trying to construct a bit of a segue into Nathan's robotic experience, because I know with Pupper it's uses a lot of reinforcement learning, and so Nathan, can you tell us about Pupper and how you address that deterministic versus training in terms of movement?
Yeah, thanks so much for having me here. Thanks, Keith, for reaching out a few months ago about the article. Yeah, so, well, let me show you Pupper first. Sitting here on my desk. Maybe I'll do a little bit demo of the AI stuff afterwards, but I'm also scared of on the spot demos. But I have confidence this time. We'll see.
Different Uncanny Valley.
Yeah. I've gone through so many different little face images for this robot. This is the latest one that I can't claim credit for. I just had ChatGPT generate for me. But yeah, so first off, I think the question was about pre-programmed behaviors versus behaviors generated on the fly by AI. And, I've been working on these quadruped robots for a while now, maybe 6 years now. And it's only in the past about year and a half that we got these reinforcement learning policies working. And for the previous 3.5, 4 years, it was heuristic-based control. And it was both a limitation kind of set by myself. I didn't know how to do this sort of AI-driven motion, and the kind of field as a whole was still working on reinforcement learning for locomotion. Only kind of a few. It was very nascent, and the results were still very early. But in the past year and a half, it's exploded. Like, I think everyone has seen videos of cool robots dancing, walking around in crazy terrain, and that's all reinforcement learning. So the heuristic stuff that I worked on for the previous robots was basically using inverse kinematics, which I think there was a cool article in this issue about inverse kinematics. So to make the robot walk, I would just program the legs to kind of go in a triangle like this. So if this is the side of the robot, you can imagine just like making the foot go in a triangle like this. Yeah, just like the drawing robot, literally. And actually, the first robot that I ever made had a diamond-shaped leg that looked just like the drawbot in that article, just flipped upside down. Yeah, and I did the inverse kinematics algebraically, like in the article, and it was a huge pain. So that's how the first robots walked, and I kind of made it a little bit more complicated so that it could go left, right, turn in a circle, that sort of stuff. Um, and then I started working with a bunch of other people on this project. Um, it garnered a lot of interest, and we had some folks from Google DeepMind helping us, and they were actually the first people, I think. So the main guy helping us was Jaitan, and I think his work was the first work to get reinforcement learning working on a quadruped robot, which is pretty awesome. So training the robot how to walk in simulation and then deploying that policy to a real robot. And I want to say this was 2019, 2018, somewhere in that time. It was still super early, and we worked with them. And even with them helping us, like every other weekend, it was a real struggle. But eventually we got it working. And there's a few key ingredients that I can, talk about later if people are interested in what made it work. But now it's all reinforcement learning based. So we set up a simulation environment. There's some pictures in the article about what the simulation environment looks like. Essentially, flat ground with a bunch of little things, obstacles in the way. And the robot trains in the simulation, takes about an hour, and out pops like a policy, a neural network that's trained to locomote. And we put it on the robot. Um, that's actually a really hard part. You can kind of, pip install RL sort of thing now, but actually getting that neural network to work on a real robot is still really hard. There's no framework that's only 2 clicks away. That's where you have to really put in the elbow grease. So that I think took the biggest chunk of our effort was after you have like a trained policy, how do you deploy it well into the robot? And that kind of comes down to boring engineering, tests and tests and tests and tests, and like eventually, by process of elimination, you've killed all your bugs, and then you can get a cute little policy working on your robot. Yeah.
Awesome. Yeah, those are the two things that I kind of thought were the most the kind of surprises for me when I was reading the article were I was kind of wondering, how's the reinforcement learning? Because if you just have the dog there and it doesn't know how to walk, and then like the first thing it does is like flail something in a way that just like tears its own leg off or whatever. But obviously you have the simulation, so you don't have to worry about damaging the robot, and also you don't have to worry about the physics or time scale of real life, and you can just do, move at 3 million miles an hour or as fast as your GPU can calculate, and then so you get all that for free or cheap compared to thrashing a robot to pieces, but then you have to fill that gap between the ideal simulation and the realistic how fast it actually takes for the servos lash to come back the other direction, things like that.
Yeah, absolutely. You mentioned servo motors. The previous robots I had used servo motors, and like you're mentioning, there's always like latency. You command it to go to some position, and it has a maximum speed and also latency in the PWM generator. And so it's probably going to be different than your simulator. So that's why we kind of had to use these a lot more expensive motors. Like servos are pretty cheap now, maybe 10, 20, $30. These ones are, I think, about $100 now, but they are really powerful and like react instantly. But good news for open source robots. I was looking at Open Duck. I'm butchering the name. Um, this
Yeah,
really
Open Duck.
cool
Yeah.
project. Yeah, and when I was reading about that project, they were talking about this other project where they were characterizing servo motors so that you can build a model of a servo motor and then use that model in your simulator so that the simulator knows about like, oh, the latency to get to a certain position and all the crazy friction stuff that goes on. So I'm excited about that because I think that will open our reinforcement learning up to a lot of people. Pupper is awesome and cute. I love him, but he's about $2,000. So, it's a big investment. Open Duck Mini is a lot cheaper. I just heard about this project like yesterday, so I have no connection. But it's great, and I hope that that kind of thing continues, and I hope that we'll see a lot more servo-driven robots using reinforcement learning. So, Michael, I think I saw that your um, Voxhead and arms and everything are servo-driven, right?
Yeah, they're also, yeah, it's meant to be affordable. So I'm, yeah, staying away from the expensive motors and things. Yeah.
Yeah. So I think like
Uh,
more and more we'll see projects like Open Duck Mini and people doing the hard work. It's really hard work to characterize these motors
yeah.
to make robots like yourself, like Foxhead, be able to deploy RL policies.
This,
Yeah, I mean, it would be nice to have other motors because servo motors make a kind of that buzzing noise, and so
Oh
it would be
yeah.
nice to reduce the noise, and have it more organic and just like yeah, kill the noise. So it would be nice to have specific motors, but you have to cost and benefits. So to keep it cheap and make it accessible to everybody, servo motors were really the only way to go for
Yeah,
Yeah,
that's
I
us.
think
always the tension in open source robotics is you want everyone to be able to make it, but you need it to
Yeah,
be
and
a good thing.
yeah, and be able to just buy the parts off of Amazon, and not have to special order everything. And
well, and I think one of the things I liked about the article is talking about, there's all these newish platforms for simulation, right? You have NVIDIA, Isaac, Jim, and these other simulator environments doing, and again, it's like the crossover between gaming world and game physics engines and
Yeah.
robotic simulation engines aren't that different, but um, even even though you can simulate it and run these thousands and thousands of iterations, there's a gap when you try and take that model and that policy and deploy it in the real world. There's just things you can't quite model because there's too many fine, there's too the backlash, the vibration,
Hmm.
the twist you're getting on the end of an actuator. There's so
yeah,
and I really like how you talk about it's called the sim to real gap, which is,
Yeah.
getting it from the software environment to the machine. You're gonna find out what you didn't simulate right because it's not gonna work.
yeah, yeah, I
Right?
agree. Yeah.
But the best way to get a head start on that is to design your robot to be easily simulated.
Yeah.
Design your robot with
Sure.
the simplest geometries or the tightest tolerance motors that won't introduce too much noise that you can't simulate accurately. Basically, designing the hardware to be easily simulated gets you part of the way there, and that's amazing. Now, what you're saying, the open duck idea is, hey, maybe we can simulate the real world motors even better at finer granularity, and maybe that will start to get rid of the sim to real gap that way, just by finer and finer and finer simulations of the components. But that's a lot of work for each component somebody might want to use.
Yeah, absolutely. Um, yeah, this robot, like you mentioned, uses these brushless motors that use FOC, another call to the article. It's a great explainer in the issue, which makes it so you have good sim to real transfer. So a small sim to real gap. Yeah, that article written by the Simple FOC folks, which is great. Um, and that's kind of the state of where we are right now in reinforcement learning. Like using reinforcement learning on robots is you kind of have to use these motors that are designed to have really good force transparency. Just means like you command a certain torque and it gives you that torque no matter what it's pushing against or no matter how fast it's going, that kind of thing. And yeah, the servo motors have terrible force transparency. And so you have to do all kinds of characterization, like put it in fancy rigs to test the friction in different situations and that kind of thing. What helped for like robot dogs is that people converged on basically the same set of maybe like three motors or and so people got a lot of experience with these certain motors. Kind of everyone's using 80 millimeter wide motors with like the same motor driver sort of thing. And so generally people like get shared experience using these motors, and the software is kind of aware that you might be using a motor like that. But that's not the case for servo motors. I don't think anyone has just published like, here is a really accurate model of random like Dynamixel or something. I mean, maybe someone has, but that I think would be a great start. Kind of an idea I've been throwing around with Gabriel, who built this robot with me, um, was we would want a sort of Lego system for building robots that use reinforcement learning to move around the real world, give them life. So we're kind of imagining you have like a few different motors that you can choose from, maybe like small motor, big motor, and a few different links between them. And then you can just put them into whatever configuration you want um, in real life or first in CAD. And then it would be like really easy to make that a digital model of it. And then you just like click a button that says train, and some server trains it in like 30 seconds for you. And you like click deploy. And then your little like worm robot or three-legged birthday hat robot like begins to move. I think we're getting there. Like maybe in the next 2 or 3 years, we'll see something like that. I saw a similar project actually online, and I don't remember the name, but that's kind of what I think would be awesome.
Awesome. Just want to remind everyone, if you do have a question for Nathan or anyone else, it'd be awesome if you could drop it into the Q&A. I see a lot of stuff flying past in the chat about Teddy Ruxpins and things like that. I don't know if there's any specific questions in there, but please do put them in the Q&A so I can see them there. I know someone asked if there was a video where we can watch it walk, and I think Keith put a link to the documentation, which perhaps has a video there. I don't know if Nathan, you wanted to actually, I don't know if you were going to switch it on or anything before. I know I didn't know if it's just going to be an inert prop or if you wanted to show it in action at all before we jump over to Lee.
Yeah, I mean, why not? Let's try. Um, so maybe I'll do like first, well, no, I'll do the movement stuff because we talked
Okay.
about reinforcement learning for so long.
Nathan, this is a research project, right?
I mean, it's yes and no. It's just for entertainment, basically.
Okay.
Use it in a few different real world applications. Like some folks at the nearby Children's Hospital are using it for kids basically that can't interact with real animals. They're like immunocompromised, that sort of thing. And it like is really fun to play with. I mean, kids always say they would rather just have a real dog, but when you can't, robot dog is pretty good.
It's great.
Okay, so he's doing his little calibration routine.
I like his built-in handle.
Yeah, handle is key. Hello.
Yes.
Might fall off my desk, so I'm just like holding his handle.
Yeah. How many servos does it have?
Fell off the desk. How many motors are we using? That's the
Yeah.
question. There's 12. So there's 4 inside the body that you can't see. And then you can see that each leg has another 2. So 12 in total.
This is great. This is great. How much?
Yeah.
So how much does it cost to build one of these things? About
Yeah,
approximately.
$2,000. I think he
Okay.
put a link in the chat to our web page, and all the information is there.
Okay.
Build their own. And we're looking for help on the kind of LLM integration, voice interaction stuff. There's a lot of fun
Oh.
possibilities, and we're just getting started. And I think a lot of people in this room have experience with that.
I don't think you mentioned, Nathan, so you can tell it to jump over a fence and it will jump over a fence?
Yeah, absolutely. You can do, 20-foot fence easily. No.
Really? Are you kidding? Or
Yeah,
Yes.
just kidding.
oh, okay. Oh, yeah.
Yeah, the first robot that
You
I
never
made
know.
was just focused on jumping. It can do like a 3.5 feet. But then we were like, wait, we'd rather build robots that are accessible and cheap and everyone can build. Yeah, so thank you so much.
Awesome. A couple things in the
That's
chat real
great,
quick.
Nathan.
Michael says, I hope that NVIDIA's Isaac GR00T N1 can help AI development with robots. Not sure if you're familiar.
Huh.
If you figure it out, write an article.
Yeah, there's so many. There's about 10 different platforms I want to test with that. Um, yeah, just a USB camera to a regular computer versus cameras going right into the nano and things.
And Sam, love just the amount of personality just from actually. That's why I kind of wanted to see the robot move before we moved on. It's just the way it moves and stuff. It's just everyone's like, freaking out by how cute it is, and it's just.
I like that it's cute too. It's like some of the ones you see coming, the more industrial ones look like they would attach machine guns to them or flamethrowers.
They do attach machine guns.
Kind of they worry me, some of those.
A little bit by chance, this one ended up with a really cute bouncy gate.
Oh, I guess you could retrain it to be more aggressive or friendly or whatever. Yeah. Awesome.
There'll be different
Okay.
breeds over time.
Well, I want to make sure we have time for Lee's piece. So Lee, did you bring any props to show, or are you just gonna describe?
Yeah, I have some props. Well, I mean, this is obviously maybe unsurprisingly coming from me is a departure from from the robots. Talk about something a little bit different.
That's
Um,
okay.
I'm normally more of like a hardware kind of guy, but I've been teaching a lot of software lately. And so I've been like trying to figure out what my relationship to software is going to be. Um, so I kind of also went back to my kind of roots in fine arts because all my background's in fine arts, and I got really into this the open press project, this open source printing press. Basically, I've been looking for like an excuse to use this for something for so long. It's a very tiny printing press. Printing presses are usually like really big. Sometimes in studios they'll have like a whole room that's just like a couple of presses. And what it does is it just like applies a lot of pressure really evenly to this platform that moves through here. So that's all it really does. It's just applying pressure really evenly. But yeah, I did this in my undergrad degree, which was in fine arts, and I wanted to find a way to like kind of make it a little bit more makery and integrate some of the software stuff I'd been doing. So I designed some of these block prints. Um, that are kind of simple, but there's a bunch of different variations of them that have like different kind of spaced lines and different like densities of dots. And I used them to create these moire patterns. So moire is a pattern I mean, now that you know, if you didn't already know about moire, you'll be seeing it everywhere. So it's an interference pattern that happens when two like regular patterns kind of overlay, and they're slightly offset. It creates these like really interesting repeating patterns. I think this is probably the most well-known. Oh yeah, there we go. Well-known moire patterns, but you can get them with like all kinds of different repeating shapes. So what I thought was fun about this was first of all I could use some software to generate the code to make these and then cut them with my laser cutter. So I used P5JS, which is really just a really great platform for artists who want to make visual stuff. And I wrote an app that is that maybe someone could drop in the link if you want, but you can go in there and make your own moire patterns if you want, and just kind of like arrange the different kinds of like circles or lines or dots and play with the different densities of circle lines and dots, overlay them, and then you can cut them out to make your own block prints. And these block prints are really small because I wanted them to like fit on the open press, which is very small. But you can do all kinds of like block printing in like large format. I actually got really excited about this because I saw this like kind of vintage computing book called Nouveau Dessin Artistique et Géométrique, and it's like a old school like how to make patterns and someone ported it to P5JS. So what I really wanted to do was kind of take this like vintage a book of computer designs and then block print them, but they were a little bit too advanced for like just too detailed to like go in this tiny press. So yeah, I think what's really fun about this is that you can't really accurately predict, like you don't have enough room really to make good registration. So you will almost inevitably, even if you print the same thing twice, you will end up with some kind of moire pattern because things they never always align. So that's kind of like a fun like trick of the medium itself. Um, I've also, I mean, hopefully I'm allowed to say this also, but like I'm working on more like thinking about code and um, like how code and art intersect. So I'm working on a zine and an article about sine waves and thinking about how you can incorporate sine waves into your code and sine waves into your art, and just kind of thinking about all like the really basic stuff that I feel like sometimes artists like I don't know like we encounter it and maybe you understand enough to like change some variables, but you don't really understand what's going on. So like really breaking it down to like the subject that I excelled least in, which is grade 8 math. And just trying to trying to get back to that. So um, yeah, that's about it.
That's fantastic. I have a question. So you said that it's hard to get the registration right. So I got to ask, was the project, did it start out as a Moray pattern, or were you trying to do something that was that was correctly aligned and then it ended up that way and you're like, "Oh yeah, I'm going to run with this."
That's a great question. So I've been fascinated with moires
Okay.
like for many years, and I've been experimenting a little bit with like projection and moire, like physical and digital projection, and just like trying to kind of play with this pattern a little bit. And I saw this artist who I think I also linked in the article, Pat Kim, and he made these rollers that are really very beautiful. They're like just repeating like lines. It's just like a diagonal 90-degree line pattern. And he rolls them onto t-shirts and he rolls them onto canvases. And just like by nature of his human hands, it always creates these beautiful and unique moire patterns. So I started out trying to make some rollers and uh, he was better at it than me. So, so yeah, I've been looking for something to do with the open press because I'm not sure if I mentioned, but it's fully 3D printed, which is really, really amazing for something that like has so much pressure. Like it has a few metal parts, like it has this roller, and it has these bolts here, but for the most part, it's 3D printed, and I think that's pretty amazing because all of the other presses I've used before are like huge pieces of industrial equipment with these big giant wheels on them, and just like seeing what can be done with 3D printers and kind of the breadth of things. Like if you could think of like the space in this world that exists between like robot dog and block printing, so I think that's pretty wild. So yeah.
I just wanted to share some stuff from the comments. Ulysses says, "This is an amazing project. Thank you for all the hard work on this." And TOC says, "Yeah, go Lee." And Keith dropped a couple links in there for people to check out. What is the material that you're printing? Is it TPU or what is the?
Oh yeah, so these the actual blocks traditionally like you might find a lot of block printing done with carving linoleum, and that's just because it's kind of easy enough to like get in there with a tool to carve it out like literally like linoleum for like construction purposes. Um And it also has like a little bit of give to it, and the give is really good when it goes through the press because it's kind of like if it's super rigid, you might get kind of an uneven print. But if it's too mushy, it's gonna like destroy your details as it goes through, right? So you have to have this kind of balance. What's really good is just like this 3 millimeter wood because it is a little bit pliable. I think it's not as squishy as I would like, but it's enough that it's not totally rigid, so it goes through the press really well. Um, and yeah, like this, like presses usually have this kind of like you can see how messy I was, but they they have like this blanket that kind of adds a bit more squish to it, just so you get those kind of even prints. But yeah, definitely like you wouldn't be able to do something like, for example, if you laser cut this on acrylic, or if you tried to 3D print it, you're not going to get the same kind of print quality because you need that like little bit of give.
Yeah, cool.
Yeah.
I got mixed up because you were talking about the machine being 3D
Yes.
printed, then I forgot that the
Oh,
pieces are laser cut, not 3D printed. Got it.
yeah,
Yeah.
yeah, yeah. The machine, I'm not sure actually what material they used because I just bought this one from the Open Press folks, and
Nice.
they actually have an even smaller one if that interests you
For
at all.
printing stamps.
It's yeah,
Alex
they're so
has
cute.
Alex has made use of the Q&A facilities. Thank you so much, Alex, and asks, what kind of ink do you use? Specific speedball inks or some such?
Yeah, so I tried a few different kinds of inks, and you want like something that's not too watery, but also something that's not too thick. So the inks that I typically have used for linoleum, which are like traditional block printing inks, they were really thick and they would get in the gaps of like especially some of these like very small. I don't even know if you could really see it, but the very small moire patterns. So I ended up actually just using silkscreen ink because it was sort of in the middle of the two viscosities.
Awesome. Any questions for Lee? Please stick them in the Q&A or the chat. Alex says, awesome, thank you. We have a couple more minutes, and I know, Lee, you also wanted to do a little promotion. Might as well jump into that if you like.
All right. Yeah. So also really excited to hear about all these open source robotics projects because I chair the Open Hardware Summit. So the Open Hardware Summit is an annual event this year. We're super excited. It's in like less than 2 weeks in Edinburgh, Scotland. And yeah, I mean, I'm just really excited to see some castles and open hardware and all the coolest people. Um, yeah, the event is also available online. So we stream. It's always free to watch at least the main stage talks. There may be a few other things that will be there as well. And we have a huge range of different projects from open source science projects, Mothbox, talking about just like creating open source hardware for monitoring nature. We have All Yarns Are Beautiful. Those folks are talking a bit about hacking. I believe they've written a couple of articles actually for hacking old knitting machines, and also Braille Wrap, which is an awesome project about creating open source braillers. So those are just like a couple of different examples. If anyone happens to be around Scotland or around the UK, we invite people to come and hang out and bring their projects. And we have a whole second day full of hands-on activities, all kinds of really weird and fun stuff. But yeah, I mean, even if you can't make it out, you can check everything. We will stream everything we are possibly able to stream over YouTube at YouTube. So 2025.oshwa.org. And yeah.
Lee, is this the first one they've had outside the US?
So last year it was in Montreal,
Oh,
which is
Montreal. Okay.
where I'm based. And then a number of years ago, before I started running the event, it's been a handful of different places, but really not very many different places. And that's our goal for the next few years is to try to broaden our community and broaden our reach and go to all kinds of different places. So, I mean, like on that note, if you feel like you live in a place that needs an open hardware summit, send me an email because we are looking for new places.
Awesome. Well, everyone's had a chance to share their projects, and now we go into the portion of the event that is just sort of a bit more of a free-for-all, where panelists can talk to each other, ask each other questions. Maybe Michael saw something interesting on the popper that you'd like to ask more about, or maybe something that Lee made that you'd like to ask more about. And again, we'd love to hear. If you can use the Q&A, it really helps us. You can also just dump stuff into the chat. Lindsay says, if you want to experiment creating Moray patterns, you can also use a couple of pieces of overlaid window screen material, like you might have on your porch.
Oh yeah, that's such a good idea. Actually, the place that I most often see moire in my day-to-day life is on on bus window gratings when they slide two
Uh,
windows together. It's always moire patterned. So like if you start to look for it, you're gonna see it in all kinds of different places. And yeah, like screens, tons of moire. Moire is everywhere. So yeah.
someone on YouTube is very cleverly saying, I'm not going to sing it, but when the lines are so fine, that's a moire.
That's amazing.
And someone else on YouTube says, or sorry, actually the same person on YouTube says, is soft robotics still a thing? Any progress there? I think any of you can answer that.
What is soft robotics again? Can you
There you
remind
go.
me?
Soft robotics is
we
not a thing
have a
anymore.
book on that. We have a book on that.
Oh,
And I think some of it was like pneumatics,
Yeah, pneumatics
like
is what I would
using
typically.
air
Yeah.
to uh and I haven't seen it come up. Easy. I'm gonna walk away and look at my bookshelf and see if I can find that.
okay.
There you go.
Soft ro Yeah, I'm not sure
Yeah.
what I can't really comment on soft robot. Is it the parts are printed in soft material or?
Well,
Yeah.
often it's inflatable.
I
Compliant grippers that may be inflatable instead of hard mechanics. Baymax from exactly. Thank you, Michael. Baymax from the Disney movie. What's it called? I forget the name of it.
Oh yeah, it's from Big Hero 6.
Yeah, it's
Tiffany
Big Hero
says.
6. Thank you.
Alex pointed out that the programmable air project for Arduino enabling soft robotics was released a couple years ago, and apparently there was something last year at Open Harbor Summit about soft
Yes.
robotics.
Yeah,
Yes. I remember
there's
that.
usually quite a bit of like e-textiles, soft robotics, and admittedly, soft robotics is my real love,
Is
not
it
Moray.
really?
Yeah.
Yeah, that's great.
Well, then it's
Yeah.
definitely still a
So
thing.
this book is by Matthew Borgatti and Carrie Love. And
Okay.
let's see, from Carnegie Mellon. Well, no, but it's from the foreword is from a person at Carnegie Mellon, but said the Baymax was from Disney Big Hero 6 was kind of an inspiration. But I think a lot of it's just making stuff that bends and moves differently than hard plastic. So anyway, maybe it's
Yeah,
a
I'll have to
reason
read
to
up on it.
rediscover
So
that.
yeah,
Yeah,
I've heard of it, but I just
yeah,
don't really know much about it.
yeah, yeah. Okay.
I was going to ask, maybe you could tell us a little bit more about the software in the robotic dog. I'm I'm curious about what you're using for the to control the dog. Is it like ROS or ROS or some kind of or are you still there? Maybe.
Yeah, I'm
Oh,
just not moving much.
oh. Yeah, maybe you could tell. I'm curious. So, what you're using for software, is it something you've written yourself, or is it commercial, or is it something that's already out there?
Yeah, it's based on ROS 2. We're using Jazzy, the latest release of ROS, and inside the robot there's a Raspberry Pi 5 as the
Okay.
compute. Let's see. So what's the whole stack look like? So we're using a ROS2 package called ROS2 Control, which is nice when you need low latency communications between like a controller and your hardware. Um, so we have what we call the neural controller, which is running the neural network
Oh, okay.
do the locomotion. And basically we're feeding the neural controller sensor information like IMU and motor positions. And then the neural controller is running the neural net using a package called RT Neural. You can kind of
Oh,
look
okay.
on GitHub. It's a nice real-time package for doing neural network inference. And then that thing computes position targets for the motors. And so that's at the top. And then when it computes the position targets, it goes to the middle layer, which is what we're calling the hardware interface.
Oh, okay.
Um, that gets those values and then talks to a microcontroller over a SPI connection. So there's a Raspberry Pi 5 at the top doing the hard stuff, and then a microcontroller in the middle that basically just does a translation between SPI commands to CAN bus communication. And Then it talks to the 12 motors over CAN bus.
Oh, okay, okay. I,
And
I actually
the,
haven't used ROS for a few years, and I haven't tried putting it on a Raspberry Pi 5. Does ROS fit on? I mean, does everything run on the Raspberry Pi
yeah, it
5?
runs
Are you
beautifully.
having?
I also had those concerns like 2 or 3 years ago when we were starting the project, whether we should use ROS or not. But Raspberry Pi 5s are so powerful that you don't need to worry about it. And ROS 2 control is a lot more lightweight. I mean, just ROS 2 in general is a lot more, I think, lightweight than the original ROS. Um, that it works
Okay.
really well.
Any frustrations? Any?
Well, you have to learn ROS basically.
Yeah, Ross is oh, yeah. I already know it somewhat, but
Yeah, I was really hesitant in the beginning to use ROS 'cause I hadn't really used ROS so much. But then
it has
we
so much built
wanted,
in. Is
yeah,
yeah.
but we wanted like it to be used. We wanted to use ROS to better fit into kind of the robotics education that happens at university levels, and so that people can plug and play with it, right? Like there's a lot of packages that other people write that work well with ROS. So that's kind of what we did. And then I happen to be using ROS for my job. So it's like I got double
Oh,
education using ROS. So in my job and on the project, it worked out pretty well. Now in my startup, we're not going to use ROS, but that's like a whole nother story.
oh,
Kind of
okay.
almost answered this already, but JStar97 on YouTube says, "What programming language does Pupper use?"
Yeah. So it uses a mixture of everything. Uh, so we use C++ for all the ROS 2 stuff. And then some more C++ on the microcontroller and the motor drivers. But the AI stuff is in Python. So it makes it pretty easy to mess around with. We also expose the interface on the robot because we're using ROS 2 and it's really easy to plug and play your own program. So you can write a program in Python that like tells the robot to move forward and turn at a certain rate. Um, and you can write that program in Python and you don't have to like touch the C++ stuff.
Rust is almost like a sort of event-based API itself, right? That you can kind of interface with in various ways.
Yeah, like we just use it as a message passing framework. So you can run like the locomotion stuff in one process and then that can like be complicated. You don't have to worry about it. And then you can write like a simpler program in another Python program and not have to worry about the complicated stuff. And they send messages to each other over the network.
Awesome. We still got about 12 minutes left, so I would love if people can jump in with any questions they have. And again, panelists, if you have questions for each other, sometimes the most exciting things that come out of these are the sort of new collaborations and new ideas that happen when people from different disciplines or unrelated projects kind of get excited about each other's stuff. So,
Sure, I wanted to go back to the soft robotics question and ask
yeah.
Lee what they thought like would be, I don't know, your favorite like, projects from the past in soft robotics, and also if you had thoughts on like if now that you've seen Pupper and everything, if you see some opportunities.
I don't know. I mean, like, it's a great question. I mean, the thing that soft robotics really excel at is making movements feel a bit more natural, right? And feel like they're not, and kind of like was mentioned earlier, like if things are like inflatable versus they are like moving in a kind of like mechanized way, like like not that I'm like specifically suggesting an inflatable dog, but like something I've seen like pretty successfully is like people using elastics or stretchy materials to kind of like create like more of like a bounce to a step or something like that.
Yeah.
I think it can be pretty challenging though, because it like introduces like a whole other mechanical challenge that I think there aren't like necessarily the same level of like resources available to like solve some of those challenges. But um yeah, I mean, I am obsessed with the idea of inflatable robots in general. I just think that's really fun. I've been like working a little bit in my own practice with silicone, and just trying to like make those kinds of things. And it's where the name of my column originally comes from is like squishy tech. So just thinking about the ways in which like we could think technology differently, or we could either like make technology that like feels or acts more like a human body. So
Yeah.
yeah.
What do you think about using a hard skeleton with like squishy outsides, or just going squishy all the way through.
I don't know. I mean, like we were talking about earlier, we don't want to find ourselves in the uncanny valley with like squishy exteriors of things. So I don't know. I think it depends on like what exactly you're trying to do, right? I think a lot of soft robotics, at least in the world that I'm in, tends to be pretty speculative, right? So
Yeah.
like just like thinking about like what we could do. Because there's no manufacturing pipelines, it's harder to buy materials, it's harder to find tutorials, harder to find resources. So um, and I would love to have like programmable air is like a great example of like
Mhm.
tools that are being made to like try to like ease that transition. But I don't know of that many um, on the market products or projects that are not like largely in the speculative world that integrate
Yeah.
soft robotics at this time.
Yeah.
Hopefully to be changed soon.
Yeah, I will mention at Maker Faire the last 2 years we've had the cuttlefish, and I wrote an article about
Yeah.
it. And it's not really robotics, but it's it's really like a vehicle, but its exterior, like the arms, are all inflatables by developed by a guy who goes by Inflatable. And it was originally a Burning Man kind of car, but the movement is very graceful.
Hmm.
Totally.
And you can put LEDs around that, and it just lights up so beautifully, so it gives you a very different feel.
All right, we got a bunch of stuff going on in the chat and Q&A now. Adrienne, thanks Lee for the shout out for All Yarns Are Beautiful Knitting Machine. Not going to Edinburgh myself, but at least two of the team will be there. Ginger says, I heard Ross is phasing out and everything's shifting to Ross 2 now. Nathan or someone perhaps can comment on
Yeah,
that.
that's correct. Ross is end of life.
So when you're
Yeah,
talking about running Ross, you really just mean Ross 2.
Yeah, don't
Cool.
touch Ross
yeah.
1
But Matt
ever.
Eaton, who I think actually next week we have a fireside chat with Matt. He wrote
Nice to
our
know.
robotic arms book. He has an article in the current issue too. He was talking about the challenge that in like college robotics programs, they have hardware that runs ROS but not ROS 2, and that they're going to be needing to change, and that will be different. It's good you have a software upgrade, but it's bad you have to kind of find new platforms for doing it.
Well, speaking of robotics operating systems, Tiffany asked Michael, your head runs its own OS?
Yeah, basically. So my frustration was actually with Ross, but also lots of other. There's a few other operating systems out there. And it's not really, an operating system is kind of a strong word. It's because it runs on top of Linux, and so I'm not sure quite what an EPI operating system sometimes I'm calling it a shell, but you're right. So that's all handwritten. I mean, so it's an operating system, and it's basically just a program written in C++ that runs other programs, so other people can come along and anything. If you can write, so it runs basically programs and it manages resources. So it doesn't allow, say, two different programs to use the eye cameras at the same time, or try to control the same motor at the same time. Otherwise, you have conflicts. So it basically avoids conflicts, with the system resources, and then people can write their own plugins in whatever language they like, Python or whatever, Lisp, if they want. Anything that runs on the command line can be run by this shell system. So it's kind of a hybrid operating system, kind of a shell. I'm not really sure what to call it. And then it has a built-in interpreter that reads its own scripting language. So there's a little scripting language that's much easier than Python to learn. So it's based on XML, and there's I think about 15 tags with attributes, and so you can write speak hello world, I'm the robot, and then so that it's very fast to be able to get behaviors up and going with the robot. So another one is play, and it can play a pre-coordinated motor sequence, or it can launch. I mean, there's lots of little commands that you can use in scripting language, and so there's a lot to it. And then logging in with your phone, that has to connect to the operating system and be allowed. If maybe the robot's already running something. If you want to connect with your phone, it basically just does kind of resource management. So that's kind of the operating system that runs on top of Linux. But yeah, I was using ROS for years, and ROS just got to be so big and bloated, and installing it took a long time. So I'm excited about ROS 2, but I haven't really played with ROS 2 on the Raspberry Pi or anything much. So I don't know much about it. I've kind of phased out ROS in my own world also.
We've got about 5 minutes left and a bunch of comments I need to blaze through real quick. I think this is a question for Nathan. Looking at the BOM list for the electronics, is there a reason for the Pi 5, or have you looked at other platforms that might be more optimized for lower power AI?
So we don't really need to go lower power on our robot. We have a big enough battery that it can last an hour or so. We on the other side though, we are looking at using a Jetson Orin or something like that, so we can do local inference. Cute dog.
Another
Is that a
one more
robot?
for Nathan.
Actually, I have a question. Maybe since we have a big community here, the Jetson Orin, it's supposed to be $250 now, but it's really hard to source for that. Yeah, it's like a 6-month waiting list. I was wondering if anybody has, especially commenters out there, knows any fast way of getting a Jetson Orin. I need a few, and I just don't have 6 months to wait. So
easiest
if
way
anybody
I've
has-
found is to go to GTC and enter a contest and win one, because that's what I did.
Oh,
But
Really
I
cute.
guess that probably cost a few $1,000s to get there, so maybe not the most efficient. And another question about the servos that you were using on the dog. Sorry, they're not servos, but can you tell us the
motors.
specifics of the motors that you're using for the
Yeah,
robot
yeah,
dog?
close enough. I sent a message in the chat. They're like a GIM 4305 servo motor that you can look at the chat message for the link.
Perfect,
Yeah.
thank you.
Hey, David, before you close, I just want to, particularly people in the audience, that the call for makers is open for Maker Faire Bay Area. And I believe last year we had Michael there, we had Lee there,
Yeah.
we had, I think Puffer was there. Was it Keith? Nathan, were you at Maker
No,
Faire?
I think we need
No?
to get Pupper there.
We need
That's
to
what I
get
think.
you. Yeah,
Yeah.
we
Come
need
on,
it
Nathan, you're the
strolling
only
down
one that isn't there.
down the walk. But at any rate, if anybody's working on
Maker
robotics,
Faire was my highlight of the year last year. It's really fun, so I recommend everybody to go to a Maker Faire, especially the Bay Area one.
But if we get enough robot projects, we'll do a robot hall.
Oh
So
yeah,
we'd love to have lots of them. So put the word out and please tell your friends.
Awesome. Excellent plug. And I want to make sure that I get Alex's question from the Q&A, because that's the preferred way to ask questions. So I want to make sure we get this in the minute or two we have left. I've seen mixed opinions on nitinol muscle wire for soft robots, complaints that it's slow and apparently requires an opposing force to return to its stretched state. Any thoughts on whether it's a good material for specific applications, or what can be done to manage those issues?
Okay. Every single time I teach a soft robotics class, I tell my art students, I'm like, and nitinol exists. And then they all immediately go bananas and go out and buy a ton of nitinol and have like a really hard time working with it. So like I think it's totally possible to do cool things, but you have to set your expectations to the right place. And also maybe you might have to do a little bit of math. So like I think it's definitely a material that is possible to use. And I don't know. I've seen a handful of nitinol actuators that kind of have like a very slow movement to them. I saw them a number of years ago. I don't know if I could pull them up again, but yeah, I've seen a couple of techniques, people putting like beads or other things on the end of their nitinol actuators to have them like return to their previous state. But it's a whole thing, and it also gets like worn out if you do it a lot and use it a lot. So it's a really cool material. It has super unique movement. It's a lot of fun, but like just be set your expectations to the right place.
Awesome. Thank you, Lee. We're just about at time. Before we hang up, though, we like to do a little sort of screenshot of everybody. Ideally, if you want to hold up like a prop or something cool, that's the best if you have something. And I'm just gonna have everyone sort of smile indefinitely until Jamie says that the screenshot has been taken. So say make.
Lee, if you don't have a copy of the soft robotics book, I'd be happy to send it to you.
We got the picture.
Okay.
All right. Thanks,
sorry.
everyone.
And by the
Yes.
way, good luck modeling soft robotics in simulation.
yeah.
Seriously.
Yeah.
Awesome. Well, thanks for all of our panelists. Thanks for everyone watching in the webinar and also on YouTube. I just dropped a link to our Discord chat. If you want to follow up with anything afterwards, that's where you can find us. But for now, I'll just say thanks everyone, and we'll see you on the next one. And we'll see most of you at Maker Faire Bay Area, hopefully.